Welcome to this lecture on Pandas DataFrame and Series. So, the data we loaded into our Jupyter notebook in the previous lecture is currently saved as a Pandas DataFrame object. And every DataFrame object has a shape attribute that will give us the number of rows and columns of the DataFrame. So we call the data.shape attribute. And the shape attribute returns a tuple, where the first value is the number of rows and the second number is the number of columns. So to begin, I'm going to change my cell here to Markdown, then create a comment which is going to read Pandas DataFrames and Series, and then run the cell. However, let's actually check to see the type of this data variable. So I can say type, parentheses, and then pass in data. When we execute the cell, then we get pandas.core.frame.dataframe, meaning the data we loaded using pandas is actually called a data frame. And you can think of a data frame as a tabular data structure very similar to a spreadsheet. But if we observe our data frame, we can see that each column contains different individual data types. So for example, if we say data, then core.info method, and then run the cell. So the .info method in pandas provide us with some basic information regarding our data frame. We can see the total number of columns and also data types of those individual columns of the data frame. So our state column is of type object. However, we can think of this object as normal Python strings, and you can also see that columns like total expenses, sales, profits are of type int64, which also stands for integer in Python. And in the upcoming tutorials, we're going to be exploring how to change data types in Python. So when working with float or integer data types in pandas, another handy feature is the describe method. When I say data and then .describe, parentheses, and then run the cell, then we get some statistical information regarding our data. And this statistical information includes the number of counts or entries of the data. And also we have the mean value of the columns, standard deviation, then the mean, which stands for the minimum values of each column. Then we have the 25%, 50%, and 75%. And lastly, we have the max, which means the maximum value of the columns. But one thing to note here is that this statistical information of our data are based on the numerical columns of our data frame, which are the total expenses, sales, profit, marketing, and then the inventory. Now, let's actually create our own data frame from another kind of data type in Python. I'm going to show you how you can convert a Python list and dictionaries into a data frame. So let's start by using the Python list. We're going to create a variable called insert and set it equals to square brackets. And in between the square brackets, we're going to add some names of insects. So for the first item, I'm going to pass in ant, then secondly, a comma, and then single quote, then cricket, comma, and lastly, bee. Now here is our Python list of insects. And if I say type, then parentheses, and then pass in the insert variable, and when I run the code, then we see that it's actually a Python list. So if we want to convert this Python list into a data frame, I'm going to say pd then .dataframe, and in between the parentheses, I'm going to pass in our insect variable. And when I run the code, then we get back a pandas data frame with a single column. And if you notice, we actually don't have the name of our column. So Pandas automatically added 0 to represent the column name. But to give our column a name, I'm going to add a comma and then columns equals to square bracket, and in between the square bracket, I'm going to pass in single quote, then the name insect. When I execute the cell, then we see the name of our column modified as insect. So we can also store our data frame in a variable. Let's call it data underscore insect equals to our data frame. And when I call data underscore insect and then run the cell, then we still get back our insert data frame. So now let's take this a bit more further by using the Python dictionaries instead of a single Python list. I'm going to create a variable called animals and set it equals to curly brackets. So as we all know, we use curly bracket to create dictionaries in Python. Now for the first item inside our dictionary, I'm going to say mammals, then a column. So I'm going to create a list of mammals using the square bracket syntax, then single quote. For the first mammal, it's going to be cow, then a comma, single quote, then the second mammal, which is sheep, comma, then the last mammal on the list, which is lion. So after the square bracket, I'm going to add a comma, then for the second item in our dictionary, I'm going to say reptiles, then a column, and then pass in the square bracket. Now for the first reptile, I'm going to pass in crocodile, comma, and single quote, then lizard, comma, single quote, then snake. Again, after the square bracket, I'm going to add a comma. For the last item in our dictionary, which is going to be insect, then a column, and then square bracket. So the first insect is going to be ant, comma, then we have cricket, then a comma, and then bee. So here is our Python dictionary of animal species completed. So when I say type and then pass in animals variable, then we see it of type dictionary. Now to convert this dictionary into a pandas data frame, I'm going to say pd then .dataframe, and in between the parentheses, I'm going to pass in our animals dictionary. Again, I'm going to store the data frame in a separate variable called data underscore animals. Then I'm going to call our data underscore animals, and when I run the cell, then we get back a pandas data frame with 3 columns. So mammals, reptiles, and insects inside our dictionary are the column names of our pandas data frame. Now let's say I want to get a single column from my data frame of animals. Then we say data underscore animals. Then use the square bracket and then single quote. So we're going to pass in the name of the column we want to get from our data frame. Let's say mammals, and then run the cell. Now we get the column of mammals from the data frame. But not just using the square bracket syntax. Another wonderful way to get a column from pandas data frame is using the dot notation. So I can say data underscore animals, then dots, and then the name of the column we want to get from our data frame. This time I'm going to say reptiles and then run the cell. Now if you notice, the structure of the column is different from our animal data frame. So let's check to see the data type of this structure. I'm going to say type, then wrap everything in parentheses. And when I run the code, then we get pandas.core.series.series. So in pandas, a single column of data is called series. And the difference with the data frame is that a data frame is basically a container or group of multiple series. For example, if we look at our data frame, it contains columns of data like mammals, reptiles, and insects. So as I mentioned, each of these individual column of data is called series, and the whole collection or group of this series is called a Pandas data frame. Now let me introduce you to a useful method in Pandas, which is accessing a row of data. So we saw how we can access a particular column, which we got a Pandas series, but if we want to access a particular row from our data frame, I'm going to call the data frame, which is data underscore animals. Then we say .iloc, and then we add the square brackets, and in between the square brackets we're going to pass in the index of a particular row from our data frame. Now let's say we want to access the first row, then I'm going to pass in the value 0. When I run the cell, then we get the first row of our data frame. So to access the second row, sheep, lizard, and cricket, then I'm going to copy this statement and then paste inside the cell below. Then instead of 0, I'm going to pass in 1. So when I run the cell, then we get back the second row of our data frame. Now if we check the type of this row of data and then run the cell, then we get back a pandas.core.series. So both rows and columns of data are called series in Pandas. Again, let's say we want to get the first and the second row from our data frame. Then I'm going to copy the statement here and then paste on a new cell below. So instead of just a single index of row from our data frame, I'm going to add a list of indexes, 0, then 1. When I actually run the cell, then we get back the first and the second row. And this gives us back a Pandas data frame since we are getting the first and the second row of the data frame, which is also a group of series. So now that we've seen the basis of grabbing certain rows and columns from a small data frame, in the next lecture, we're going to be working with our dataset that we downloaded at the beginning of this course. We're going to see how we can grab rows and columns from the sales dataset. See you in the next lecture, and as always, take care.